Okay, so here's some homework help for questions 3 and 4. So I'll start with, on question 3, I'm going to start with this angle right here that's marked G. And notice that that angle has a vertex that's on the circle. So this angle is half of the arc. So half of 150 is 75. Now I also notice that this segment right here is a diameter. And I know a diameter splits a circle into 180 and 180. So this is 150. So that means D must be 30. And then because this arc is 30, angle C, which has a vertex on the circle, is half of 30, is 15. All right, next step, I'm going to take the 78 degrees, and it points from here to here. So if this angle is 78, it's half of the arc right here. So what I need to do here is 78 times 2 minus 91. And find out that A is 65. If I add 65 and 91, I get 156, and half of that is 78. And now that I have these arcs, the only thing that's left is B, so I can just subtract those from 360, and I will have the rest of the circle. I'm trying to find the best way for you to see this. There we go. So 360 minus 65 minus 91 minus 30 minus 150. Angle B is 24, or B degrees. All right, so we can find E and F in a couple of different ways. I'm just going to use the inscribed angles again. If you take F and go from here to here, F is going to be half of this arc. So 150 plus 24, and we'll take half of that. That's 87 for F. And then for E, if you trace it out, it goes here and here. So it's half of this arc, which is what, 89. So 65 plus 24, and divide that by 2. That makes E 44.5. So it's all about knowing where the vertex of the angle is. When it's on the circle, it's half of the arc. And if you need to, just trace the angle and see what arc it's pointing to. And always look for diameters because they're useful. All right, number 4. Here we go. So I noticed a couple of things in number 4. Notice I have a couple of parallel lines right here and right here. And also notice that we have a diameter right here, and we've got a radius. All righty. So one of the things we need to know about our parallel lines is that when the lines are parallel, the arcs that are in between are congruent to each other. So that kind of comes in handy. So if I start with this C, I notice that this 19-degree angle goes with the C. The angle is half of the arc. So 19 times 2 means C degrees is 38. And we just said that because the lines are parallel, C and D had to be the same. So D is 38. Now, remember the other day we talked about central angles. Since E has a vertex at the center, the angle equals the arc. So that makes E 38 degrees. So remember, on the circle is half of the arc, at the center is equal to the arc. What can we do next? I'm going to look at angle B. Notice that B goes from here to here. Well, if you remember, this segment was a diameter. So this arc is the entire semicircle, which is 180. Since B has a vertex on the circle, it's half of the arc. So this is 90 because it's half of 180. Again, we have a diameter. So the arc is 180. So 180 minus 38 is going to give me the value of A. So A is 142. And all we have left here are F, F, G, and H. Over here, this arc is also going to be 142 because remember, diameter cuts the circle into 180. So we have 38 and 142. So H is half of 142 because that's the arc it intercepts. So we've got 71. Now look at this triangle right here. And we're going to try to find F and G. If you notice, this is a radius and this is a radius. So we've got ourselves an isosceles triangle. That means F and G are going to be the same. If we could just figure out one, we'll know both. Since E is 38 degrees, this angle right here is going to be supplementary to the 38. So I'm going to subtract from 180 and find out that this is 142 degrees. I guess I could have figured that out from the central angle. So in my isosceles triangle, since F and G are the same thing, 180 minus 142 is 38. And that means angle F is 19 degrees and angle G is 19 degrees. So that's how we did all of that. Hope that helps.